Hello, everybody.
Good morning. My name is Greg. I will be speaking today about compute, past, present, and the future. This talk is a little bit generalized and not too specific into Akash. But I felt there's a need to go back a little bit and really talk about why we are here doing what we're doing, because this new generation of protocols seems to have lost that. We used to have quite a bit of these kind of talks in 2017 that I enjoyed quite a lot, but somehow we got too much into the weeds and really, I think, lost our way a little bit. So this talk addresses the past, the present, and really the future, which hopefully is a bright one. My name is Greg, the founder for Akash Network and the CEO for Overclock Labs. Uh, been an open source contributor for about 15 years. Um, Prior to Akash, I founded a company called Angel Hack, responsible for bringing hackathons to what they are today. Some of the code I wrote got me notoriety in the open source space. Some of my libraries are very actively used by the cloud infrastructure products. I've been trending as top 10 programmer in the Golang category several times. And as you can see, I'm the only human being here in this list, right above Golang, which is a language that is very prominent for infrastructure products, including the Geth tool that is the primary client for Ethereum written in Go. It's interesting to see, like, the internet really began in 1969 on this notion of decentralization, decentralized systems. And somehow, fast forward to today, we got locked down and bogged down to this few companies that control the infrastructure that's supposedly decentralized, but no longer. The question you should ask is, how did we get here, right? Well, to think about it, in the 60s, computers meant a large mainframe. It meant you go to a large device and you use that and borrow your time from there. And with advent of personal computers, the shift really, you know, shift really happened towards individualism, um, uh, and uh, and powerful devices coming together that is at the client, at the user. So that led to distributed networks built on open protocols, which we see today, which is called the internet, right? So heavily centralized systems shifting to more, uh, significantly less powerful decentralized systems, which led to the innovation that we have today. And the need for coordination layer began essentially because these smaller devices were not as powerful as one large system. And that one large system, the need for one large system came about, what we call today the cloud computing. As we see the enterprise spending today, a large swath of it goes to this layer called the cloud that we don't really know much about, right? And if you look at the IT spend, about 70% of the spend is on the by the hyperscalers, as we call them. Really, about four companies spend about 70% on IT equipment. And one might ask, what's the outcome? Well, what's the outcome is the vendors and this entire infrastructure that is supposedly built the decentralization layer that we all enjoy is now optimizing towards building or towards the needs of the few, right? And that leads to heavy, inefficient distribution of resources. There was an article in Semaphore. In fact, if you look at what happened in the last 1 year, there's this dire demand that came all of a sudden for these accelerated computing units called GPUs, which is a lifeblood for AI. And this article in Semaphore really dives into the story about a student trying to do machine learning and could not really get the resources or the chips that he wanted on Amazon Web Services, but could go into this decentralized networks and be able to actually do his work. But it tells you today, it takes about 18 months to 2 years if you want to buy these accelerated computing chips or GPUs from this maker called NVIDIA, and it's nearly impossible to rent on the cloud, right? I mean, you get the chips if you are selected by the cloud providers to be something that benefits them, and and also the cost, right? Andreessen Horowitz did a study and wrote a paper called the $1 trillion paradox, where they research S1 filings of cloud companies, and turns out half of every dollar you spend on one of these cloud companies goes to on one of the cloud services, be it Netflix or Asana, goes to one of the cloud providers, one of the 4 cloud providers. And what this effectively is a cloud tax that we all pay, but don't really realize we are paying to this group of unelected individuals or entities, right? And the reliability is questionable. Not sure how many of you heard of what CrowdStrike was before the recent event. And quick show of hands is how many of you were impacted what happened by CrowdStrike. I really want to see. There you go. A good portion, right? And CrowdStrike is a unknown company, a security company that provides software for pretty much our American infrastructure or global infrastructure. It went down recently because somebody pushed bad code. Not a nation state actor, not a hacker. Somebody pushed bad code, and that took down our entire airline industry. Thousands of flights were canceled. Thousands more were stranded without being able to get to their homes, or without accommodation or food, as a matter of fact. It caused such an incredible chaos in our infrastructure. And what my question? What are these services? Why is there such opacity that we have no idea what's happening under this on these seemingly important services that we all depend upon, right? And the industry is known for their antitrust practices. Amazon Web Services is currently under investigation by FCC, along with several others, because they tend to create, or they have effectively created these moats that makes it impossible for new companies come and innovate. I mean, this is very remarkably similar to the railroads in the 1870s, to the oil companies in the early 1900s. A very similar pattern we are seeing with this seemingly one of the layer that keeps our humanity together, right? The cloud computing, which is a fabric that holds a modern society. And I mean, it's very obvious that centralization leads to extremely high cost, and this is no longer efficient in terms of economic distribution. So one might ask, what is the risk? What is the risk of going down this path, right? And things are okay, prices are cheap, but why are we talking about this heavy centralization problem? Well, the big risk as a society as a whole we have is the return of feudalism. Feudalistic society is where few have power over the many, because the few today are the ones that are running AI. The few today are the ones we call the modern spies, right? The few today are the ones that control who should get access to this extension of our intelligence or augmentation of intelligence, and that few hold a lot of power. And there's this discussion about artificial general intelligence. What happens when somebody cracks it and no one knows that they cracked it? Because there's no incentive for them to share this AGI, because they can very well go and play in the stock market or do things that are significantly advantageous to the few. So if we don't do something about this layer, we go back to feudalism. And that's the risk that we have. And I coined the term digital feudalism because it's exactly what's happening in the industry today. And this is a future that's bleak. This is a future where corporations or the digital lords control humanity as a whole. And it's industry sentiment. Obviously, this is not a sentiment from me, but we all in the industry felt this need, and and it's very obvious to the public, and that gave birth to this decentralized, cloud infrastructure layer that we talk about. Now, decentralized computing is real today. It is it really represents the founding principle the internet was founded upon, and why? Because compute should be a public utility. Compute should be as free as the air we breathe and water we drink, um, so that innovators everywhere, from every corner of the globe, have the tools to build and create and transform without barrier. And that's really what we have, what we want as a public utility. And it's very important that we return to sovereignty, right? Sovereignty, control over what gets built, control over what goes and touches our daily lives, and we as people that use this technology should be in control over that layer, and not few unelected, opaque players that decide what we get and what we really how we think, right? That's the danger that we're in, and decentralization really solves us going back to sovereign society that we were. Well, democratization, right? I mean, with in the story of in Semaphore that talked about how the student couldn't find resources on Amazon Web Services, but could come to Akash Network and really get access to H100 and A100s. And that led to him creating a new company, which eventually got acquired by NVIDIA. So without a decentralized network, this student will be still probably, hidden away in a corporate, desk somewhere, till, trying to get resources from this digital lords. And that's what decentralization leads to. And obviously, big benefit is the prices. I mean, if you look at decentralized technologies today that offer similar, if not better, resources than what you would otherwise get on centralized systems at significantly lower cost. Akash Network is an example where you can get the same amount of compute that you get from AWS for 80% cheaper. And the reason for that is decentralized systems can reach places where centralized systems cannot or could not typically. In case of Akash Network, it goes to closed off networks, corporate networks, where there is heavily underutilized compute. I mean, if you look at today, GPUs, which seemingly have incredible amount of demand, and really, while the demand is increasing, the supply chains are not quite catching up to produce new chips. But if you actually look at the industry, there are a lot of chips available, right? There are chips now available in crypto companies that were doing mining before and no longer profitable, or machine learning companies that did training with a set of chips now upgrade their fleet because they want to train a new model, are setting this large swaths of GPUs. There are a lot of chips available. I mean, and also if you look at the data center usage, about 80% or 85% of the time, most data centers are not used. Why? Because you need to have peak capacity to address peak workloads, and that leads to inefficient distribution of resources. Decentralized technologies like Akash Network can reach these closed-off systems and bring those networks to the users that need them at a price point that's significantly lower for the same exact quality that you otherwise would get on a centralized system. And they tend to have incredible reliability. And the reason for reliability comes from few areas. One is obviously the way the network is distributed. It's not controlled by a single client, Akash, or a single node. Akash has been alive for about 4 years. It has not gone down a single time. Whereas if you look at networks like Amazon Web Services, it goes down about 200 times a year, right? So including CrowdStrike, famous example. And the reason why Akash is incredibly reliable is because there's not a single company or a single a cluster that controls the network, but rather a distributed network of nodes that interact with each other in a peer-to-peer manner without a central point of failure. And this is a classic example. And also from a code standpoint, Akash is not, well, what you have an incredible property of being open source is the code is available for people to audit, the people that use the software to audit. right? So recently we had an example where there was an exploit that could impact all of Akash users. There's an exploit in the authentication mechanism that accidentally got pushed to production, but before anyone could get impacted, there was a company that identified this exploit, pushed a fix, and deployed or wrote a proposal to update the network before anyone could get impacted. And that's the power of open source systems. Even though there are human errors, and human errors cannot be eliminated, that's why we call fault tolerant and not fault avoidance. And the key property of fault tolerance is how quickly we recover from faults, and decentralized systems tend to recover much quicker than centralized systems because of code being open source and because the impact or the attack vector can be minimized to few nodes. And if we can figure out a coordination speed, we win, right? This really is the new way. This really is the new era of innovation. And this is the future where creativity isn't stifled, it's unleashed, right? And that's really the future we are building with decentralized systems, and it's real. Today, if you look at this new sector called DePIN, or decentralized physical infrastructure networks, there are enormous amounts of protocols in the computational cloud computing layer. We have protocols like Filecoin that decentralize storage, protocols like Akash that decentralize compute, Lightyear that decentralize video rendering, and a whole lot of incredible services, all delivering with amazing value at significantly lower cost and incredibly high reliability. And this is real. This is the future that we dreamt about 5-6 years ago, but this is the future that's real, right? In terms of Akash Network, Akash is the world's first decentralized supercloud with a premise of connecting any cloud-capable compute, usually from places where it's heavily underutilized. And the way it works at a high level is the users that want resources describe what they need and package their application in a container and place an order on the marketplace in the order book and providers that can offer these resources bid on this order in a reverse auction mechanism, and the tenant eventually selects the provider that they want. There are about 65 providers on Akash Network. That is double the size of Amazon Web Services. Amazon has about 30 different regions. Akash has about 65 regions, and thousands of compute and hundreds of GPUs, all working incredibly well in a decentralized manner and in a fully open source manner, right? And the ecosystem is growing. These are some of the amazing examples. The biggest user of Akash today is NVIDIA. Akash tend to believe Akash is the only protocol integrated into NVIDIA products. And the reason for that is because the chips are so hard to come, even NVIDIA finds it hard for delivering chips to their users. And there are a lot of chips available. The Akash's model of tapping into these closed networks where even NVIDIA cannot, because once they sell the chip, it's no longer in their control, is actually beneficial to their customers because there's enormous amount of compute available out there. Some of the other innovators, News Research. News is known for, they recently came out with this incredible technique called distro, which really is a practical way of leveraging decentralized GPUs for machine learning training. So for context, training has been extremely hard to do on a decentralized or distributed networks because of latency requirements, but News has figured out how to do that on Akash Network. So Akash is unlocking this new generation of companies that are able to get resources that they couldn't get from traditional cloud, and really pushing the humanity forward. And another incredible example is Venice. Venice is one of my favorite tools. I use Venice a lot. It is a private, uncensored ChatGPT built on open source models, right? And the reason you want privacy is because, I don't know how many of you use ChatGPT, but it has something on memories. It's kind of creepy because it remembers everything about you. So that makes me extremely uncomfortable when discussing my health or things that may not agreeable by half the country, right? So any political questions or any of my private data that I'm not very comfortable sharing with ChatGPT, I use Venice because I know Venice doesn't share my private data with anyone. So it's incredible. Tools like that are being built right now in Akash, and it is live. You can use. Highly recommend folks to go check out Venice AI. All the AI that you're seeing in Venice is running on Akash. Incredible quarter. We've been growing amazingly well ever since the introduction of GPUs. In Q4, we can see the growth. We measure our growth in something called leases. Leases are applications deployed in Akash. And in last quarter or quarter before, we had about 27,000 applications deployed on Akash. So before I end my talk, I really want to leave with one closing thought. As we stand in the crossroads of this technological advancement called the cloud, the choice is really ours to continue down this path of centralization or embrace decentralization and unlock a new era of innovation and empowerment that unlike nothing else that we have experienced. So with that, I'll take any questions. Latency for an end user, like applications deployed on Akash, or latency to access the Akash network? Right, reliability. Right. So the question is, well, your trade-off between reliability and cost, right? So Akash being cheap, that means it may not be reliable. So Akash is not just a cheap network; it's a marketplace, right? So you get a wide degree of providers, some seemingly significantly more reliable than the others. So Akash lets you granularly specify the parameters and select the resource that you want, a significant level of granularity compared to any other network. So, and there are real reliability numbers available for you to choose. So sometimes you may choose a highly reliable provider that may be expensive, or sometimes if your application can support hyper fault tolerance, you can go choose a slightly less reliable provider, but for a cheaper cost, right? Akash is a marketplace that opens up, but does not deliver or guarantee any SLAs or any of the reliability guarantees that you need. That depends on individual providers. So it depends on provider. But there's also a new mechanism called a reclamation, pre-agreed reclamations that we're working on. A big challenge with Akash or decentralized networks in general is if you're computing a task on a provider, if the provider want to reclaim the resources, they tend to take off the node offline and use them because the whole notion is underutilized supply. What that means there's going to be some use sometimes for that underutilized nodes, right? So we're working on something called a pre-agreed reclamation where the tenant and the provider agrees on a reclamation time that is optimal for the application to either a hot swap to a different provider when the provider reclaims the resources. So there are solutions that we can use to offset the reliability issues using pre-agreed reclamations. Any other questions?
In that diagram you showed, there are a lot of different providers for a lot of different services. One of AWS or any of the big cloud providers offering is we have everything you need. How can a network like Akash or someone else in the space connect all the different providers and all their different services? So if someone wants to host something on decentralized infrastructure, they go to one place, one infrastructure as code, and they have access to all the services.
Right. So to summarize the question, Amazon, Google, and Microsoft of the world offer managed services above these resources, right? And these managed services are super helpful because even though I'm pretty technical, I don't want to manage my own database. I don't want to manage my, load balancers and cache servers and whatnot. I rather pay someone a premium to do that for me because I value my time. Very good question. So Akash, next, part of a longer or midterm roadmap is to have a managed services marketplace. But unlike Amazon, where you have one provider, Akash will have multiple managers, right? So typically what happens today is Amazon is offering these services that are essentially open source software white labeled as Amazon services. So that hurts the author of the open source software whose only business model is hosting, right? So they stifle innovation that way. And we want to change that. So the way we're going to do that is to allow the open source author or a company that the author is partnered with to offer their services directly to customers, cutting out the middleman, Amazon's web services. And we believe if we empower this creator network, the chances of our success is higher because these creators tend to be extremely influential people, right? So if I'm a creator of Redis, if I'm benefiting of offering hosting services of Redis on Akash, I'm going to be spreading the word to my users. And open source is has a very high degree of loyalty in terms of users, right? So open source resources or open source services need an open source network. And I think crypto and decentralization has a significantly higher chance of success. And we sort of seeing that with BitTensor a little bit. We have BitTensor subnets that are effectively services that have incentives to offer on the network, and they're able to attract quite a lot of talent. And in a similar way, we're doing for managed services that like databases and caches and data warehousing services. You'll probably see them in a year's time on Akash. Any other questions? Awesome. Thank you so much.